All right, this is section 2.1 over congruent figures. And congruent figures have the same shape and the same size. Okay, so they're basically the same exact figure. Okay, you can see in the example down below, maybe one has been rotated a little bit, maybe it's been turned, it can be moved, it can be flipped, but congruent figures all have the same shape and the same size. Congruent, the word congruent means not only same shape, same size, but the actual word means equal measure. Okay, so not only can shapes be congruent, but angles can be equal measure, side lengths can be equal measure. The word congruent is it's used mostly in geometry to talk about things that are equal. Back hundreds of years ago and thousands of years ago, it didn't make sense for mathematicians to say, it made sense that two numbers could be equal, but it didn't make sense for two objects that weren't numbers to be equal. They didn't have a word for that. Equal was only something used with numbers. So congruent meant that the two shapes were equal, since those aren't numbers, right? Or the two side lengths or the two angle measures were the same measure. So that's what congruent means. And in congruent figures, we've got corresponding sides and corresponding angles. And the word corresponding just means the same, in this case, side on the other shape, or corresponding angle will be the same angle on the other shape. And in congruent figures, those corresponding sides and corresponding angles are equal. Okay, so in the two triangles that we have below here, we've got matching sides. We've got AB, which is going to match with DE. Those are corresponding, and they are the same length, so they're congruent. We've got BC, which is congruent with EF because they're corresponding sides. And then we've got AC, which corresponds with DF. They're corresponding and also equal. So in this first example, let's match up all the corresponding angles and the corresponding sides. We've got two trapezoids here, trapezoid ABCD and trapezoid WXYZ. And since they are congruent, it says they are congruent, we know all the corresponding angles and corresponding side lengths will be congruent to each other, so they'll be equal lengths. So angle A is going to be the same as angle W. That's the angle symbol right here. Sometimes people draw the angle symbol with a little angle measure in between there, so that's possible as well. We've got angle B matching up with angle X. Angle C is going to match up with angle Y. And angle D matches up with angle Z. So those are all the corresponding angles. And then for the side lengths, this little bar on top that you see here, that refers to a segment. So that's a side length here. So side length or segment AB is going to correspond with segment WX. And BC corresponds with XY. And CD corresponds with YZ. And DA corresponds with ZW. ZW, there we go. So those are all the corresponding side lengths and angle measures, and they are all congruent. They're all equal measure. So something we'll talk more about as this chapter continues is congruent statements. And for a congruent statement, this is where you match up all the corresponding angles and side lengths as you're describing two figures that are congruent. So in this example, we've got two triangles here. So we've got triangle, that's the symbol for triangle, ABC, is congruent to, and we actually have a symbol for is congruent to. It's an equal sign with a squiggly line over it like that. That means congruent to. So we'll use that a lot. We just use that symbol in the last example. And when we write this, we can't just put any of the letters in any order that we want to. Once we've said A, B, and C, we have to match up those corresponding angles. So angle A was the same as angle D. Angle B was the same as angle E, and then angle C was the same as angle F. Okay, so that's one way I could write a congruent statement for this, and you'll see all the corresponding angles match up, and then also the corresponding sides. If you look at side AB and side DE, it's the same side. of the triangle. They're corresponding. Or maybe if you look at side BC and side EF, they're also the same side on the right here. Okay, so they all match up. Another way, so obviously alphabetically just makes sense, but another way you could write a congruent statement for this is you could say triangle BAC is congruent to, and BAC I started up here and went this direction this time. So then I would start and do triangle EDF. And these are both acceptable. There's more than one way you can write a congruent statement as long as all the corresponding angles match up and you've done it correctly. So let's write a congruent statement for these pentagons here. I know they're pentagons because they have 5 sides. So let's look at the one on the left here. Pick any letter that you'd like to start at, any vertex you'd like to start at. I usually choose the top. And then once you choose that, you can either go clockwise or counterclockwise, but you cannot skip around. So I couldn't go pentagon K, N, L, J, M. That just doesn't make sense. I could not do that. I've got to pick a side or pick a vertex and then go either counterclockwise or clockwise. So I can say pentagon, and I'll just abbreviate that P-E-N-T, pentagon K, J, N, M, L. Okay, and so I went counterclockwise there. So then I've got to pick that matching side over here, which was R. But these two pentagons, so is congruent to pentagon, these two pentagons have been reflected over a line here. So I cannot go counterclockwise this time because Q, angle Q here, does not match up with, gosh, I can't get, there we go, angle J. It does not match up. It's not the same angle. Angle Q actually matches with angle L. You can see they're the same angle. And then we've got this right angle down here for V and M. So I've actually got to go this direction so that they match up. So R, pentagon R, S, T, V, Q. And then you can double check. Angle M was the right angle on the pentagon on the left side, and angle V was the right angle on the pentagon on the right side, and M and V are in the same place, so that makes sense. We've got angle Q being the obtuse angle that's above the right angle, and angle L being the obtuse angle that's above the right angle, and Q and L also match up. And you can just do that. Make sure when you write a congruent statement, all those corresponding angles match up. And if they do, then all the corresponding side lengths will then match up. This next example says, which square is congruent to square A? Well, remember that congruent means same shape, same size. All of these are the same shape, even though square C has been rotated a little bit. But square A and square C are the only ones that have the same size. So square B is also the same shape because it's a square, obviously, but it doesn't have the same size. It needs to be congruent, so to have the same size, square C needs to have 8 for each side length, and it does. So square C is congruent with square A, where we would say square B is actually similar, is the word we would use. Similar and congruent are two words that almost mean the same thing. Similar means same shape but different size. And that's not what we want here. All right, so this next example, we've got two trapezoids we're looking at. Trapezoid ABCD is on the left side, and trapezoid JKLM is on the right side. Now look how they did the congruent statement here. They said ABCD, so A, then B, then C, then D, and then they did the same thing for this next one. J, then K, then L, then M. So all the corresponding angles are matching up there. It says, what is the length of side length JM? Well, because side length JM corresponds with side length AD, you can see JM up here corresponding with AD, then I know that they're congruent, which makes JM 10 feet. And then it says, what is the perimeter? Well, if the perimeter of trapezoid ABCD is 6 plus 8 plus 8 plus 10, So let's see, 8 and 8 makes 16, plus 6 more is 22, plus 10 is 32. So if the perimeter of this trapezoid is 32, and all these side lengths are the same as the other one because they're congruent, then that makes the perimeter of trapezoid JKLM 32 feet. And then it says in part C, which angle of JKLM corresponds to angle C? Well, you can see visually it's these two, right? But if these trapezoids had been rotated or flipped and it wasn't so easy to tell, then I could always use the congruent statement up here, which says C and L, which are in the same spot, would be corresponding to each other. So angle L is the angle that corresponds there. And finally, I had to do some sort of challenge for this because this section is just way too easy. Here we've got two quadrilaterals. You can see we've got PQSR, and that's congruent with WTUV, and WTUV has been rotated, so it's hard to match up these corresponding angles. This is what I was talking about with, you look at all the other ones, you're like, why do I have to write a congruent statement? Well, this is why, because it's really hard to match up these angles and side lengths unless you have a congruence statement that we're going to use to find out what X, Y, and Z is. So X, where is X? X is right here. And X is the side length, part of the side length of RP, right? So RP, I go here, RP is going to correspond with VW. So where's VW? It's over here. So I can write the equation, x plus 5, and since corresponding side lengths are equal, x plus 5 is going to equal 12. So that makes x equal to 7. Now, for the next one, y. Y is, where's y? Y is right there. Okay, so y is the side length of TW. So I go over to TW, which is right here, and then that means PQ is going to correspond with that, and PQ is right here. Okay, so maybe you didn't think those correspond. That's why we have to use the side lengths, or we have to use the congruent statement to find the corresponding side lengths. So then 6y is going to equal 24 since corresponding side lengths are equal, and that makes y equal to 4. So I've got 2 of the 3. And then finally for z, z is right here, and that's part of angle V. And angle V is going to correspond with angle R, which is right there. So I've got 11z equaling 132. And you probably know that 11 times 11 is 121, and 11 times 12 is 132. So I've got x equals 7, y equals 4, and z equals 12, and I have to use the congruent statement to find the corresponding sides and angles here. And once I do that, this is a piece of cake. So if you have any questions, let me know.